Hello everyone and welcome to our presentation. Today we have part 2 of the presentation which started last week, and it is called Energy Footprint of AI, Current State and Alternative Paths. So I would start first with a theory which was forwarded by the founder of a company called Palm. If you remember, maybe 20 years ago, it was a very big, very popular company, and now probably not very well known. But his name of this founder is Hawkins. He had a theory related to his rejected PhD thesis at Berkeley that the neocortex of the human brain can be uniformly mathematically modeled. Hawkins stayed in the background for decades, but very recently researching at his company called Numenta. In 2021, he published 1,000 Brains, a new theory of intelligence, laying out his neocortex-based AI model and ideas. In the 1,000 Brains theory of intelligence, it represents a bold departure from the today's mainstream AI frameworks. Rooted in the concept of hierarchical temporal memory, this model belongs to a new class of brain-inspired approaches that aspire to mimic the human brain's inherent energy efficiency. Alongside neuromorphic computing, spiking neutral networks, liquid state machines, and deep predictive coding networks, the 1,000 Brains points towards a future where AI doesn't merely process data, but learns to operate with the efficiency of our current biological organisms. Hawkins' theory posits that human brains learns through a neurosensory mapping by building three-dimensional models of reality from sensory inputs. He suggests that unlike other brain's region, the neocortex is structurally uniform areas responsible for vision, touch, language, look, and these regions look remarkably similar. This led him to propose a universal algorithm unifying all neocortical functions centered around the cortical column, a vertically organized structure of 6 neuron layers, each specialized for distinct processing tasks. Humans possess around 150,000 to 250,000 of these columns, each with roughly 80,000 to 120,000 neurons. And Hawkins' theory sees each cortical column as a small independent processor capable of recognizing patterns and sequences. These columns work together, each identifying patterns at various levels, but they communicate selectively. One column connects with only few others and not with everybody else. This decentralized approach allows the brain to build a cohesive view without a central control point or a Cartesian map. Instead, each column independently processes sensory data through predictive coding, collectively creating our perception of the world. Imagine holding a baseball. Out of thousands of cortical columns, only about 2% fire, each contributing a fragment of sensation, a touch, a sight, uh, a sound. Together, these columns vote on what they're perceiving, waving a collective impression, the lived experience of a baseball ball. Brain-based models evolve and improve. The AI infrastructure today swells with ever greater investments. The question looms, how much is too much? Is AI a bubble? Investment in AI has become strikingly lopsided, heavily favoring semiconductors and infrastructure over the development of actual applications. NVIDIA's data centers alone have an astounding 105 billions in annualized revenue, while prominent AI applications from OpenAI, Anthropic, and Midjourney together bring in comparatively modest $5 billion. The cost to train models like GPT-4 is around 880 million, but projections for GPT-5 are an order of magnitude more, with some estimates as high as $2.5 billion. This has promoted and prompted some to question whether we're amid an AI or Transformers bubble. We have witnessed this kind of infrastructure boom before. Back in the late 1990s and early 2000s, companies poured resources into preparing for an anticipated explosion in internet traffic, with some projections forecasting data demand to soar up to 100% per year. As a result, Level 3 communications, Global Crossing, Q-West Communications, and WorldCom rushed to lay miles of fiber optic cable, anticipating demand that ultimately fell short. By 2004, only about 5% of this infrastructure was in actual use. WorldCom spent more than $30 billion, which is equivalent to $56 billion today, on acquisitions and network build-outs, only to collapse under an accounting scandal in 2002. Global Crossing, after investing $22 billion at that time and equivalent to $41 billion today in fiber, faced a similar fate, declaring bankruptcy that same year due to overcapacity and crushing debt. Level 3 and Q-West managed to survive, but their stock prices plummeted by up to 90%, weighted down by debt from their overbuilt networks. Whether AI is in a bubble depends partly on how quickly more efficient models become commercially viable and whether AI applications can deliver on promises. If brain-inspired models see widespread commercial use in the next 5 to 10 years, we are certainly in a bubble. But how we design these systems is a far more important question. Like this researcher and like called Joshua Bach and other such so-called AI reductionists such as Geoffrey Hinton and Yanli Gunn and Meta, who argue that intelligence can be created on any viable substrate by constructing mathematical models that break down complex phenomena into manageable pieces. They believe that holistic emergent properties can arise from sufficiently complex systems, and that this approach is a particular way to approximate and simulate intelligent behavior. Others propose that we take a more holistic approach to design and that reductionist models will eventually run into the limits that a researcher called Gödel discovered in his incompetitiveness theorems. And Pascal, centuries before him, and John von Neumann, Bohr, Poincaré, Russell, Wittgenstein, Hume, and Kant, each described in their particular ways. Rationality has hard limits. They suggest that AI be built to include a bigger picture perspective that guides rationality, because a reductionist approach could lead to unpredictable and unwanted outcomes. Ironically, or perhaps through design, these two uh, competing philosophical views mirror the physical separation within human brains. One side of the brain embodies a pure reductionism and rationality. The other is a holistic observer. At first glance, this divide may seem inconsequential. Humans, after all, thrive on debate, and in the end, one might assume that the most practical design will prevail in the marketplace. But as you might have experienced already, AI output is notoriously difficult to quantify. As artificial intelligence grows increasingly complex, assessing accuracy and bias becomes more elusive. The philosophical approach is critical because it will guide smarter systems than we are. The direction we choose has profound consequences. In our choice, if our choice is inconsistent with reality, it could have dire consequences. Before delving into how this perspective will shape the future of AI, let's first examine, because it is pivotal to the future of AI design, how each hemisphere of the human brain perceives the world and how that came to be. And with this said, I'm ending this presentation, and I'm coming back to the beginning of this presentation, where I failed to mention that my name is Paul Arsov, and I'm the founder of the Decentralized Web project. Currently, we're working on several projects. The first project that I want to mention is the actual Decentralized Web project, where we are building decentralized communication and advertising platform. And this project builds on a vision of decentralization, which is separate from what is the predominant thinking. Decentralization is that it is based on blockchain technology. Blockchain technology has multiple fundamental flaws and limitations, which prevent it from being a driver of decentralization. In our vision, decentralization is about direct communication from user to user without going through one or more additional parties like web servers. The communication between our users in a decentralized way is from one-to-one, peer-to-peer, and it avoids going through a third party, and by avoiding going through this third party, essentially it enhances the privacy, it enhances the security of the messages which are exchanged by the users. So it is very easy for a government entity to go to a central point like a website and command the owners of this website to share information with the government for the so-called national security purposes. Big countries, especially US, China, Russia, they do this with their own local large companies, like in the US, for example, with Google, with Facebook, with Microsoft, which is the owner of Skype, and with many other famous or not so famous companies. In China, the same thing happens with WeChat, AliExpress, some large commercial providers like Baidu, and in Russia they have their own search engine and a platform called Yandex. They have multiple other platforms like Telegram, which are also popular, and they could be compromised if solutions like our decentralized communication is not taken into use. I want to mention also that the decentralized web project is supposed to be monetized through advertising, and we have a specific way where users can place ads. It's very permissive, and users are rewarded actually for viewing advertising. With this said, I'm ending talking about this first project. I want to mention a second project called 3D NFT project, and so it is about releasing a marketplace and collection of NFTs based on three-dimensional objects. With three-dimensional objects, there has to be a special software which reads the file of the 3D object, then it opens a display, it loads the file, the 3D object, and it displays the 3D object. Creators of 3D objects, traditionally they have been using software, commercial and popular software, which does what I did describe, opening a display, loading, displaying, and maybe moving this three-dimensional object. Currently, the creators are mostly having two popular choices. One of them is called a game engine called Unity. The other one is also a game engine called Unreal. But from the very beginning of our 3D NFT project, we decided to build our own 3D software engine, and what it does is it opens a window on a computer screen. It loads the 3D object, it displays it, and it starts animating it in a way of moving it in a random way around the window it did open. But in addition to these basic capabilities, our 3D software engine has multiple additional capabilities. The first additional capability of our 3D software engine is the capability of speaking. The 3D NFTs can speak in one of three basic voices. The 3D NFTs can speak either in a male voice or in a female voice or in a whisper kind of a voice. In addition to the three basic voices, there are three different flavors of voices. A voice can be spoken either in a normal speed manner or in a fast speed manner or in a slow speed manner. In addition to this basic capabilities, in addition to this first capability of speaking, the next and important capability is the capability of voice recognition. The 3D NFTs can recognize voice commands, and if, for example, you have a 3D NFT which is animated by moving in random fashion, then you can issue your very first voice command to the 3D NFT to stop moving. And then the 3D NFT is going to stand still and stop moving. You can issue following voice commands to the 3D NFT to move left, move right, move up, move down, zoom in, zoom out, rotate. And then the 3D NFT is going to fulfill each one of these separate voice commands and move left, then move right, move up, then move down, come closer, zoom in, go further away, zoom out, and start rotating. The third additional important capability for our 3D NFTs is the capability of them having basic artificial intelligence. Wow, really wow. You can ask the 3D NFT what is your name, and then the 3D NFT is going to reply with their name. You can ask the 3D NFT who are you, and then the 3D NFT is going to reply with in few sentences of who they are. You can ask the 3D NFT to describe something. For example, describe Web3 or describe decentralization or describe Russia. And then the 3D NFT is going to describe in few sentences about Web3 or about decentralization or about the country called Russia. The last additional but not least important capability of our 3D NFTs is the capability of them being displayed in a way of stereoscopics. What stereoscopics means is that part of the 3D NFT is going to be displayed in red or reddish colors, and another part of the 3D NFT is going to be displayed in blue or bluish colors. Then you can come to our website of the 3D NFT project, and probably now is the time to tell you the name and the URL of the 3D NFT marketplace. It is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by 3 other letters NFT, and it is all together 3D NFT. Then there is dot, then there are two words, decentralized and web, and they're typed all together, decentralized web. Then there is dot and it ends with org. On the top of the screen you'll see a number of links. One of these links points to links to accessories, and when you click on this link you're going to see that we're offering special glasses. When you order one pair of these glasses and receive this pair, you're going to see that one lens of these glasses is red and the other lens of these glasses is blue or cyan. Then you can put these glasses on. You can request displaying of the 3D NFT in a way of stereoscopics, and then you are going to see um, the 3D NFT as coming out of the flat two-dimensional computer screen, and you're going to see it in real 3 dimensions. With this said, I'm ending talking about the 3D NFT software engine and collection of our 3D NFTs, but I like to mention our 3D NFT marketplace. What is interesting and unique about our 3D NFT marketplace is that we have our own 3D, we have our own blockchain instance. And this blockchain instance runs the same software which is running on Ethereum mainnet, it is running on Binance Smart Chain, it is running on Polygon Matic Chain, it is running on Avalanche Avax chain, and it is running on many others, famous and not so famous blockchains. By having our own blockchain instance, then we do not charge our users to pay gas fees for the deployments of the smart contracts for the non-fungible tokens, and we do not charge our users to pay gas fee for transactions of transfer of ownership from one user to another user. But by having our own blockchain instance, also we detach the 3D NFTs from a single crypto coin, and now we allow buying and receiving proceedings from sale with multiple crypto coins. Currently, the choices include Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin, which is a big centralized crypto exchange. They have a coin called KCS. In addition to buying and selling with crypto, we have a second parallel and independent way of buying and selling 3D NFTs, and it is done entirely in fiat currency. Our users can come to our NFT marketplace, and they can click on the composite image of our first collection. Then they're going to see all of the items in our first collection. Then you can browse through the items. You can see one item that they like. They can click on it, and then they're going to see a short video of the 3D NFT as it is moving, and then they're going to see a drop-down menu which is asking to select payment either with one of the 4 crypto coins or a fifth choice of paying with fiat currency. So let's say you are an user and you select payment with fiat currency. So what is going to happen then is when you click on the button to advance next, you're going to be presented with a screen where you have to put the number of your debit or credit card, expiration date, and CVC. When you click on the button to complete the transaction, what is going to happen is there's going to be a transaction and transfer and conversion from your national fiat currency, which could be different than US dollar, and this converted to US dollar transaction is going to be deposited in our bank account in US dollars. Then we're going to follow this action with a transaction and transfer of the initial ownership from our 3D NFT marketplace to you, and now you become the current owner of this 3D NFT. So let's say you play with this 3D NFT for a while, then you decide to put it for sale. You decide on the price you want to put the 3D NFT for sale, and then let's say there is a second user, they come to our 3D NFT marketplace, they browse through the 3D NFTs, and they see and like in particular the 3D NFT that you put for sale. The second user is going through the same path of like selecting between crypto coins and the fifth choice of payment with fiat currency. So let's say they select payment with fiat currency, then what is going to happen is when they complete their transaction, there is going to be a transfer and conversion from the national fiat currency of the second user, which could be different than your national fiat currency and different than US dollars. And this converted to US dollar transaction is going to be deposited in our bank account. Then what is going to happen is there is going to be a transaction and transfer of ownership from you, the initial user, to the second user, and now the second user becomes owner of this 3D NFT. And we are following this action with the third action, and transaction and conversion from US dollars to your national fiat currency, and this transfer and transaction is going to be deposited in your bank account in your national fiat currency. With this said, I'm ending talking about this second project. I'd like to mention a third project that we are working on. The third project is about electric vehicles, and we anticipate increasing and at some point maybe exponential growth of electric vehicles. With this exponential growth, there is going to be a problem in charging of these electric vehicles, and currently the way of charging of electric vehicles is done in a way similar to the way internal combustion engines are loaded with fuel. The owners of internal combustion engine cars, they come to gas stations, they connect the hose, they pump fuel in their car, they pay, and then they leave. In the same way, currently there are some small number of stations built with columns where owners of electric vehicles they come, they connect electric cable to their electric vehicle, they start loading electric energy to their car, they pay, they stay for a while, and then they leave. But we estimate that the number of these charging stations is going to become ultimately insufficient to handle the exponential growth of electric vehicles. So what we are proposing and what we are building products for is based on a new model, and we call this model the parking lot model. In this model, owners of electric vehicles which are living in high-rise buildings, which these buildings have ground floor where the residents of the building they park, or they may be having multiple underground floors of parking lot. So we're building products which can be mounted in the parking lots, and the owners of electric vehicles, when they come back home in the evening, they could connect the electric cable, start charging their vehicle, and the vehicle is going to be charging during the evening, during the night, and early morning until the owner of this electric vehicle leaves for work. But in the same way, like owners of electric vehicles, they may be working in a high-rise office building, and in the same way, this high-rise building may be having ground floor parking lot or multiple underground floor parking lots. In the same way, this building could be outfitted with the kind of products that we're building, and the owner of this electric vehicle, when they come to work, they can connect electric cable to their vehicle. They can identify themselves by their debit, credit card, or some near-field communication token, which could be in the form of a credit card or a keychain token or a ring which you can wear on your finger. And this the car which is left in the parking lot of the office building could be charging during the morning, afternoon, and maybe early evening while the person is at work. With this said, I like to tell you the name and the URL of the website of this project that we're working on. It is power.rstack.com. Power is the ordinary word for power, then there's dot, then there's something which sounds like rstack, which I can spell it letter by letter. It's Alpha, Romeo, Sierra, Tom, Echo, Charlie, Hotel. Altogether rstack, then there's dot, and it ends with com. Like on the, we have article posted which describes in detail comparing the gas station model versus parking lot model, and also the website contains 3 different surveys which we posted. One of the surveys is on the hardware, the other one is on the software, and the third one is on the features. You can fill one or more of these surveys and let us know if you require a special product, which could be a customization of our existing products or a new product that we can build to satisfy requirements of a specific vendor and a specific customer or organization. Like as I mentioned, our product contains remote control capabilities. It is connected to internet, and this is very important capability because it can every charging station that we make can measure the electric energy which is consumed moment by moment and aggregate it, and these numbers, aggregated numbers, can be submitted to a specific organization because business electric energy consumers, they have a specific envelope which they should not exceed, and when they exceed this power consumption envelope, they are going to be charged significantly higher rate. In the same way, the power utility has at every moment balance the generation capability with the consumption capability. By having measurement of electricity consumed by our chargers, we can report this energy to the electric utility, And in addition to this, the electric utility can have the capability of scheduling turning on of this chargers at a specific moment, so that the generation capability does not become insufficient, which could lead to blackouts to specific neighborhoods, cities, or even regions of country. With this said, I'm ending talking about this third project, and I like to mention a fourth project, which is about building of intelligent devices. With this project, we are building devices which combine computer vision, it combine speech capabilities, maybe voice recognition capabilities, it combines motion capabilities and the capabilities to grab and move things from place to place. We anticipate that the current wave of investments which are focused on machine learning models and like large language models or other like image models, we estimate that it is not the right path to artificial general intelligence, and we think that robotics is going to be the next frontier, which is going to come after the current wave based on statistical technologies and machine learning and modeling. With robotics, we are entering and we are building capabilities in this area, which we estimate is going to be leading edge technology in a very, very near future. And we do not have yet a website of this project, but you can contact us and we can share what we're building, and we can also build and release website for this project very, very soon. With this said, I'm ending this presentation. Thank you for listening. Thank you for viewing. Have a nice day. Have a nice evening, and goodbye.